All right, welcome back. So now we're going to talk about substitution or start into the Calculus 2 material. Now, I don't think I can overemphasize how important substitution is just as a general problem-solving technique, okay? It really should be one of your main problem-solving techniques. The reason is that substitution is, I like to think of it as changing a problem you don't like into a problem you do like. Okay, that's a smile. You're taking a problem you don't like into a problem you do like. All right. So let's first get just a little bit of theory, and it comes from the chain rule. Okay. So if we recall our chain rule, we have the derivative of f of g of x equals f prime of g of x times g prime of x. Okay, so alternatively or conversely or whatever, I don't know the proper word, the integral of f prime of g of x times g prime of x dx is going to be f of g of x. Okay? Let's add that c. Okay, don't want to miss that. Okay, so let's do just a couple of really simple examples. Okay. Let's start with, say, the integral of sine squared of x cosine x dx. Okay, so what we can do is we can say, okay, well, you know what I notice is that cosine of x is the derivative of sine of x, so I'm going to make a substitution. I'll make u equals sine of x du. Okay, this is just the way that we write it, is, no negative there, cosine x dx. Okay, so what I see is that here I have du. Okay, now that's not really what I do, or not how I teach it. Really what I would say is let's solve to get dx. This isn't let's say mathematically correct, but it is correct in the sense that there's a truth here that works. Okay, so sometimes we have to do stuff that works even if it's not formally correct. Well, we're going to say it's correct because it's not algebraically wrong. It's not wrong. Okay, so it's just going to work for us. Okay, so this is sort of the way we're going to do it. So we're going to put this dx in here. So we're going to make the replacement. I actually love doing this on the iPad now, or on screens, because what I can do is I can sort of say, okay, this is my replacement. I think about putting my integral through my replacement, and my integral becomes, now sine is u, so we've got u squared du, and that's just going to be u to the third over 3 plus c. Now I have to go back into my original, so I get Sine cubed of x over 3 plus c. Okay. All right. Now, I'm going to do that same one, but I'm going to put limits of integration on it now. Okay. Changes things a little bit. It changes the process a little bit. Okay. So when I didn't have limits, I have to go back to sine. I have to go back to the x because this u, well, it doesn't, I changed the problem. This u really only exists within the context of of my work. So if I give you this and you give me back this, well, no, that's not really the answer. I need to see it in the original variables, okay? But in this case, actually, almost a little bit easier. Okay, so we do the same thing. U is sine of x. Du is cosine x dx, solving. Okay, now what's going to happen is this integral becomes now the integral. Now here is where sort of things get a little bit nice. I can change my limits of integration because I'm asking for a numerical answer. So now, if x is 0, sine of 0 is 0. If x is pi over 2, sine of pi over 2 is 1. Okay, so now I make my replacements. And this is a valid numerical answer. Okay, I didn't have to replace it back because I took my limits with me. Okay, in the substitution. That's what I want to do. Okay, that's generally what I'm going to be doing. Okay. All right, so let's take a look at another one very similar. Okay, we're going to look at another one very similar. We're going to do the integral. Now we're going to do from 0 to pi of sine squared of x cosine x dx. Okay. In this case, when we do our substitution, we're going to get now sine of 0. Oh, let me do the substitution. Sorry about that. Now, when x is 0, u is 0. When x is pi, u is 0. Oh, wow. Yeah, it's u squared du, but that's 0. Okay, it didn't matter. So what happened here? Well, if we think about this, this is sine squared times cosine x, right? So graphically what happened, okay, if we think about cosine of x, okay, from 0 to pi looks like that, right? So this positive part and this negative part canceled out. Interesting. Okay, so you want to try to exploit these ideas. These things work like that. Okay? All right. I will see you all in the next video.